All right, now we're on to part 3, which is actually calculating z-scores. Calculating z-scores. So there's a way that we can do this algebraically. There's a formula. Remember, the z-score is the number of standard deviations away from the mean, how far you are to the left or the right. The formula is z equals, it's x minus, this is mu, this is the symbol for the mean, divided by the standard deviation. X is the data element, it's the element, the number that we're testing, the number we are testing. The mu shape, that is the mean, and then the circle with the little tail on it, that is the number for the standard deviation. So those are the 3 things we need. In number 4 here, using the information above, calculate the z-score for Candace Parker. She's a WNBA player. She's a professional basketball player. Now, because Candace Parker is a woman, we're going to use, for females, the mean was 64 inches. The standard deviation was 3. And the x value is 76. So that's the element, that's the number that we're actually testing. X is 76. So we're going to go to this equation, z equals, we take the x value, which is 76, and we subtract the mean, 64, and we divide by the standard deviation, which is 3. Now she's above the mean, so we should be getting a positive z-score. If we subtract, we get positive 12 divided by 3. So her z-score is 4. She's basically off the chart. 3 standard deviations is really as high as the chart, as the graph, the curve goes. She's off it. Okay, that's how tall she is. Yao Ming is a professional basketball player who retired a few years ago. He is 90 inches tall. Now he's a male, so the mean for male adults is 70. The standard deviation is 3, and the element, the number we're testing, is 90. Z equals, and so we're going to go 90 minus 70 over 3. The element minus the mean divided by the standard deviation. 20 divided by 3 is 6.67. Just to explain how high that is, if we are going back, I'm going to go back to the front for a second. Here's your normal distribution curve. Here's 3 standard deviations. 0.1% of the population is to the right of that. Now Candace Parker is at 4, so she'd be here. Yao Ming is close to 7. There might be 100 people, might be 1,000 people in the world that are as tall as he is, probably less than that. So that's how high that value is. All right, let's take one more person here, part C, Spud Webb. Spud Webb is a former NBA player who was actually very short, but he played in the NBA for years. He was pretty impressive. The mean is 67. The mean is 70 because he's male. The standard deviation is 3. But the number we're testing, notice that it's less than the mean. So if we take his number, 67 inches, his height, subtract the mean, divide by the standard deviation, and what we get is negative 3 over 3. His z-score is actually negative 1. He is below average, and that's just for regular adult males. So imagine this guy playing in the NBA. He must have been really good to be that short and to still be able to play professionally. For the last problem we'll do here, number 5, part A, calculate the z-score for your height. So let's say, again, your height is 68 inches. That's going to be x. I'll do this for males. So the average male height is 70, and the standard deviation is 3. So the z-score would be 68 minus 70, so we're a little bit below the average, and we get negative 2/3, and as a decimal is negative 0.67. Now the percentile, we already did that. We looked at it here. So negative 0.6, and we went over to the 0.07, so it's 0.2514. So your percentile, I'll change that decimal to a percent. So you're in the 25th percentile. What that means is that you are taller than about 25% of the population, or you can say 25% of the population is shorter than you. If you were in a group of 150 people, let's say that it was normally distributed, how many people would have a lower height? Well, we would take 25% of that group. So we would multiply, and 0.2514 times 150 is 37.7. So approximately 37 people would be shorter than you. And what that also means is that out of 150, how many would be taller? It would be about 113. So you can do it for short, or you can also figure it out for taller. And that is the end of the notes.